Hello and welcome back to the channel where we are building a video game from scratch using Love2d and Lua. Yesterday we got this temporary artwork bat in the game, and we're doing it a little smarter than we used to, which we have our own bat entity. Our bat is an entity class, and we give our bat a bat walk state. That's what we did yesterday. So now we have the ability to only give bat logic to type of bats. So right now all we're doing is setting our delta x to be a negative value, so all it does is walk to the left. But what we need to do is have the bat track our player. So it's not like the geckos where they either track you horizontally or vertically, but the bats will literally fly right up to you, and they'll kind of they'll stop just short of you, right? Because they don't fly up and hit you with their bodies. They're gonna fly up and then kind of spit at you. So we're gonna see if we can get some AI for the bats to track our player today. So yeah, I'm very low energy today, but we're here streaming, so hopefully it's not the most boring thing on earth. We've got this library to tween values. I'm not sure that's what we want to use. It's like a timer.tween or something. I'm forgetting how we use it. Oh, here. Timer.tween. Okay. I don't know what we're doing here. Finish function. Let's see how we can use this tween. So we want to let's take this as an example of how to use it. And it looks like, what is this? Transition speed. This might not be the best example of how to use it. Transition speed. What is this transition speed? See, this one makes more sense. So this one, what is the transition speed tween? Because this is like what is the finish we're using on here on this method? We say also finish. I don't know, but here's an example. Gosh, we're gonna have to look up the usage for this. So it looks like it takes, I don't know what the 0.9 is. Oh, the time to tween. Okay, so let's say that it takes 3 seconds to tween a value. Tween stands for between two values, right? So the first argument is the time to tween, and then it takes in a table, and it takes in an object as well as a table of which values from that object you want to tween into what. So we do want to tween, it's not the player's X position, but our self.entity, because that should be our actual bat. So we say our self.entity is what we're trying to tween, and we're trying to tween the X value of it. And let's just say we're going to tween it to 0, 0, tween it to the top left. So we're going to say the X becomes 0, the Y becomes 0 over the course of 3 seconds. And this is only in the walk state. So since the bat takes a little while to go from idle to walk, it should be stationary and then fly up to the top left. Oh my god. I can't believe that worked. But the issue here, hey, what's up, Loki? Hope you're having a good evening. The issue here is that we don't want to just tween over time like this. We want to... Yeah, I think tween is the wrong method to do this, because I think what we need to do is just give us... I might have to draw this out. Because, like, let's say our player's at the very top left, 0, 0. And our bat is at the bottom right, which is like, let's just say 100, 100. We need our X value to become closer to the X value of the player, as well as our Y value closer to the Y value of the player. So we need a certain speed at which to deduct. We need to calculate like player's current X value, see which direction we need to move, and then move a unit of direction closer to the player until we're a certain distance away. So I don't think tween is the way to do this. But let's say that once we are, and I'm going to put this before we assign our X position, just because that makes more sense in my head. Okay, so our bat, we need access to our player, which is our global player. So we basically want to say, I think we might need to do a get distance. Well, let's not worry about that yet. Let's just try to match our bat to our player's position. So we just need to say, do we have to say if our player's X is to the left of us, move left? Or we can just, how would we modify? We need to modify our bat's X position. So the X position of our bat needs to become closer to the player, which either needs a negative value or a positive value, right? And whether or not it's a negative or positive is dependent on if our player's X is to the left of us or not. So I do think we have to say, if our player X is smaller than our bat's X, then we want to update our X position by a step amount, or whatever we want to call it, like a unit of distance, right? So like this would be if player's to the left of us. So if the player is to the left of the bat, we need to update the bat's X position to be equal to its current X position, but we want to move it left. So we would say minus a unit, whatever that unit is. For right now, let's just do this, where we'll say there's a unit, and it's just going to be a 0.5, because I think 1 is going to be way too fast. I think 0.5 is going to be too fast too, but we want to say, if the player's to the left of us, move our player leftwards. That's all we're going to do. So let's just see if we can get the bat to move leftwards to us. And we'll start over here. Come on, man. Okay, so it does want to move leftwards to us, so that's close. We're getting that weird pixel issue for the animation for it. I don't know why that's the case. We might need a pixel of buffer there, but else, this would be if the player's to the right of us. We need to remove the geckos so they don't get in the way. So right here, we'll just take off the geckos. And then we want to modify this by a positive unit in order to move it to the right. So now our bat should track our X and oh gosh. Did we? I think we took, well, I think we might have accidentally removed all our entities. This, we just, yeah, okay, yeah. We want to just take out the geckos. Okay, so we should have a bat. It should track our X position. So once it turns on, well, okay, yeah, once it turns on, see, okay. It does this weird shifting stuff, and it's probably because we're not doing, well, I don't know why. But see, what is this? Like the leftmost pixel here is getting screwed up. Why is it doing that? I'm gonna take a look at our bat lists, right? Let's see. I've had this issue in the past, and it normally comes because there's no pixel gap in between these two. This, dude, Windows sucks. How can it look that bad when we try to open something? What kind of blending is it trying to do here? I don't know how to fix this problem without giving it like a buffer. A pixel buffer in between the frames. But I really don't like that I always have to do that. Oh, we messed up. We messed up. Yeah, it looks like this is the beginning of the frame. Yeah, we just messed up. We just put him wrong. Or we exported him wrong. I think that would be okay. Let's try to save this. We didn't do that exporting. I mean, we check-marked the export as Atlas. But maybe that's why. Maybe there's some hidden setting that's putting an extra pixel in there. Okay, yeah, that looks right. Other than, see how he's like wiggling here? If we were to print up his value there, it'd probably be very strange. Well, actually, let's do that. If we go to our bat walk state, we can print up what its X position is fairly easily. We just say we're going to print up not the entity's health, but the entity's X position. And we're going to put it... Yeah, that could get a little messy. Let's just try that. I don't think it's going to be... Oh, are we not seeing it? Oh, it's only in the walk state render. So once it kicks on, it should print up the X position. Okay. See, what is it oscillating between? I only see one number there. I don't get... let's look at where we do this. you know, we say if our player is smaller than our x. Okay, so I guess we can do it where we can say like, at the end of the day, this doesn't really matter either because we're not ever going to get this close to us. But it's nice to kind of just try to do this where if the player's greater than our bat, it's to the right of us, self.entity.x, then do this. So if our bat's x position is equal to our position, meaning we've met ourself, then we're not going to be updating the x position because now we have this explicit instead of an else. So that should fix the wobbliness. Nice. So yeah, that doesn't wobble anymore. I think that speed is actually maybe okay because we're faster than it, which is good. So that's a 0.5 speed. We call it unit. We should probably call it bat speed. Something like that. So let's do that. So instead of unit, what we'll do is say that it's called a global bat speed. And then we'll just define that bat speed as 0.5 in our constants. Okay, so let's get rid of the x position print and we'll try the y position print. So here is the bat. Oh, and you know what? This should be in... This should be in the process AI function. But yeah, this should be in the process AI because do we run this anywhere? Process. We process the AI for our bat, I'm pretty sure already. So, well, let's just try it. Let's just, if we place this junk here in the process AI, let's just see. Because I think we're already processing the AI for the entities, and it looks like we are. That's nice that that works. Okay. So let's get, we could, yeah, we could rename this. We pass it as a player, so we can just change global player to player. It doesn't really matter. And we can call it Tashio even. I don't know. Doesn't matter. Doesn't matter. Okay, so we don't need this if entity is bat because we're in the bat walk state. We know our entity is a bat. So we should just be able to process the AI, which is this matching X position at least. And then we can match our Y position as well. Now the tricky thing becomes diagonal movements, because it'll move twice as fast on the diagonal because it's getting, you know, a consistent unit in two directions. So we might have to do it based in quadrants, because we have to scale the unit by 1.4 root 2 in order to offset the diagonal velocity or whatever you want to call it. So we might have to do it in quadrants. You know, what is the best way to do this? You know what? I don't think it is necessary because the bat will never be equal to the player, so it'll always be moving in two directions. Well, unless it's equal to our... Okay, yeah. Crap. What's the move? Because we need to say if you're just to the left of us and your y is equal to us, then just move at your bat speed. But if you are a diagonal away from us, meaning one of your values isn't... If neither of your values are equal to the player's values as a bat, then you need to move at a 1.4 times bat speed. So yeah, because there's what? There's 4 instances where we would move at just a bat speed, and that's if only one of our values does not equal the player's value. So let's do that first. Well, let's do all the bat speeds first, and then we'll do the diagonals. So if we're just to the left, first we'll ask, we have to make sure that our player y is equal to our self.entity y. We could... Oh, yeah, let's just do this. So if our y is directly equal, then we just want to move by bat speed and not the diagonal scalar. So if our y is equal to the bat's y, then we just move to match it, whether left or right. And okay. And then I guess if we might need an else here, because we need to manually kind of set our entity's x. Well, because this is saying if we're to the left of us, if we're to the right of us, so else, if neither of those are true, then our entity is equal to... see, this just becomes... It depends if we're properly truncating the player's x and y position, because we could subtract a bat speed because we're to the left of us. Yeah, see, we could get stuck alternating in between. It's hard. Yeah, that's kind of hard to explain, but it's like if our bat's just to the right, like let's say the bat is like I guess since bat speed is a 0.5, let's say we're 0.5 pixels to the right of our player. Then it's going to say, okay, well, since we're to the right, we're going to subtract a bat speed, which gives us 0.5, which makes us equal to the entity x. Okay, so we might be okay. As long as our player's x position is getting truncated to the nearest 0 pixel, that should work. So here is our y is equal. We're at the same height as our bat, so we need to move just directly left or just directly right. And then we need the counter one, which is our x position is equal to our player. Then we need to substitute any dot x with dot y. And then, if our y is smaller, that means if the player is above the bat. And then if our y is greater, that is if the player is below the bat. Okay. Now this is still only if our x and y position is like exactly... Well, let's just see what it does. I don't think it won't move diagonal just yet. Only if we're exactly equal to either the X or the Y will it move towards us, I think. Oh yeah, see? Only if we're exactly equal. So we still need the diagonal. I can't get the Y working. Damn it. Let's print up the Y for the bat. Okay, so if our Y is equal to 93, it should move towards us. Oh, and it does. It's just hard to get it there. Okay, so that does work. Okay. Okay. Okay, so we have the singular directions, fine. Now we need the, you know, this is just orthogonal movement, and then we need diagonal movement. Okay. So let's just start top left and go counterclockwise. You know, if our player X would have to be greater than our self.entity X, and our player X would be to the right of us and bigger than our Y, so self, it is greater than, oh, we have to ask this again, and player X is greater than the Y. Then this would be if player is what, top left? Up left of bat. Because the player X, no, would it be greater? No, it'd be bottom right. Let's start at up left. If the player's up left, that would mean that the X position would have to be smaller than the X, and X position, and then the Y would have to be smaller than the entity Y. So that should be if the player's top left of the bat, up and to the left of the bat. And if it's up and to the left of the bat, we need to modify both the X and the Y value to become bat speed times 1.4. Because 1.4 is root 2. And that'll cancel out the two movements. So let's say that our entity X position will become entity, you know, we need to move, if the player is up left of the bat, we need to move our entity to the left. So we need to move it to a negative bat speed and then multiply the 1.4, which is root 2. We could or should do math dot squirt of 2, because it's really 1.14 or 1.4 or something. And then entity dot Y, our bat would need to move up, so we would do a minus bat speed. So entity dot Y, subtract our bat speed, and then scale by that square root of 2. So that should be if the player is up and to the left of the bat. So let's see if that works. We're up and to the left of the bat, so it should move diagonal. It was way fast. It was way fast. Bat speed times... Yeah, it's not... Oh yeah, 1.4 is too fast because it's... I think we have to do half of this value. I don't know. What do? We do this in... Because 1.4 is like the velocity we need to scale it with, but we're doing 2 directions at once. So we need to half that adjustment. I'm sure there's a better way of doing that. Nice. That looked good. But see, then it doesn't track just left. So something's going wrong here because we're not becoming exactly equal. Yeah, we're never becoming exactly equal on the X and Y. If our player X is smaller than this and we move diagonally. Okay, so I think if we're just not becoming exactly equal to our player's X or Y position, and then it's saying that one of our positions is met, so maybe we do this. Crap, I don't know. Yeah, because it's basically getting to the point where we're setting our bat's X based on this point. Oh, we might just need to floor this number. We might need to floor it because we're going to be getting a weird truncated number. But we can't floor it. If we floor it, we get rid of the data. We can't floor it exactly. Because if we were to print up what X or Y values actually showing up here, it's going to be a point a bunch of digits number, right? Yeah. So we get like a whole bunch of digits. So that's why it's not matching us on the X or Y, because in order for the X to meet it, our player's X would have to be 47.9962, which it'll never be because we're truncating it. So, and we can't just floor it because it makes the math wrong. Because we're working on a Game Boy scale here, so even like fractions of a pixel off over time is like a huge error in rendering. Let's see where we're doing a math.floor for our player and see how we handle that. Want to see it in our, here in our walk state. We do, it looks like we do just freaking floor it. Let's try to just floor it and see how off it looks. So once we have, you know what? Yeah, it's going to be jacked up. I think the move is if, how do we do it? Because we don't want to just willy-nilly floor it. We want to round it to the nearest pixel. So if it's 0.49 and below, we want to floor it. If it's 0.5 and above decimal, then we want to round it up. So in order to get the decimal, do we divide it by itself and take the modulo? I don't know. Let me ask ChatGPT real quick. We're trying to round the value to the nearest pixel, and we can do math.floor and seal. So how they do it is you take a value with a point remainder, you add 0.5, and then you floor it. That's really smart. That's really smart. Okay, so let's do something like this where outside of our outside of our update function here, we're gonna add a method to our bat walk state. Yeah, we're gonna add a method here, and it's gonna be called bat walk state. Well, it's not a method. It's not a method we want to run on the walk state. It's just a function. So we're gonna call it round to nearest, and it's gonna take in a value. And what we're gonna do is we're gonna say, well, we're gonna take local. We can just return the, and this is what ChatGPT said to do. You're gonna floor the result of the value plus 0.5, which is really smart. So like instead of doing a math.seal and math.floor, you just add 0.5 and floor it. So if it's under 0.5, flooring it will take off, will truncate it, and if it's above 0.5, it'll truncate it to the next number above it. So that gets the desired result. So all we do is return the floored value once we add 5, and then all we have to do is just call that function, and that will return the new value. So we can, where is our process AI? Right here. So after we're done processing our AI, we're going to say that our entity X is going to get assigned the value of our round to nearest, and we just give our current X position the argument to the round to nearest, and same with Y. So we're going to round both of those. So now let's print up the Y just to see that we are printing up. We're actually printing up the X position, so we're just going to see if the X position is rounded. It's not moving at all. See, this is the issue we always run into. So maybe, oh god, this is bad. Because that means our bat speed is 0.5. Yeah, see, because our bat speed doesn't modify our position bigger than a whole pixel, so we're just rounding to the nearest, which is just erasing all the value adjustment we are supposed to add. So we need a better way of doing this. Instead of rounding, this would be like if we're within 1 pixel, if we're within 1 whole pixel, not exactly equal to the pixel. So we can say if the absolute value of the difference of these values if the absolute value is less than 1, is less than 1 pixel difference, then go ahead and match. I think that'll work. We could Yeah, I don't think the truncating is. Yeah, I don't. I'll have to look how we're doing the truncating for the player X position. Oh, you know what? We only do it upon lifting a keyboard input. I think that's what it is. So that makes sense because it's like I think we have. We can see it. So like, let's just get this almost working, and then we'll look at how we're maybe doing it for the player. So we're gonna take our player X, we're gonna subtract the entities.x, and if that value is smaller than 1 pixel, we're gonna go ahead and just move directly diagonal. Otherwise, we're gonna move up and to the left if our player is up and to the left of the bat. So we should do that, and then we should move left. Yes. So if we're close to the, maybe we need 2 pixels here. Oh god. Yeah, maybe we need a difference of 2 pixels. Because 1 was just a bit too strict. But then again, once we have the other directions, it'll match easier. It'll track. Yeah, okay. 2 might be good. 2 might be too. Oh, what was happening there? What just what? Why did he move all weird like that? Why? What the? Why is he moving all weird? That has to be. Oh, we might be messing up. We might be hard coding in a certain width for the entity in our collision detection, because our bat is a weird length. So I think when we move him upon a left collision, we might be moving it based on like a baked-in 16 when he's longer than that, or something weird like that. But let's do if our player is bottom left of bat. So if the player's bottom left of bat, our X would be left and our Y would be greater than the entity. And then we'd want to move the bat to the left. We'd want to move the bat to the left and up. So we would just change this. Okay, now let's try the other diagonal, and it'll be if the player is up and to the right of the bat, which would mean that the player would have to be to the right of us and smaller than us on the Y because it's above us. Then we want to move the bat upwards, so we would subtract a bat speed, and we'd want to move it rightwards, which would add a bat speed to the X. And then we need our last direction, which is if the player is bottom right of the bat. And bottom right of the bat would mean that our X would be to the right, so greater, and the Y would be bottom, so it would be greater than our Y. And if that's the case, if the player is to the bottom right of us, we need to move down, so we need to add the Y. And we need to move to the right, which is add the X. Okay, so we should have 4 directions. We should have all the directions of the bat chasing us now. Let's see. Oh, see, the collision is way off. We get triggered by the collision way off. I'm curious if we just do a set color, red, and then we just draw a rectangle right where we are at the width and height we are, and see if that matches the bat transparency. So It takes in a fill type, and then it takes in an x, a y, width, and a height. Self.entity .x, x, y, width, and height. Okay. I think this is going to be way off. Yeah. Oh, we have it at the old square size. So that is just way wrong. So where do we set? Oh, it's in the declarations. When we make our bat, yeah, see, we have the same old width and height here. So what we need is the updated width and height, which we get from our dependencies. BATC is 24 and 10. So 24 is width and 10 is the height. So that should fix it. 24 is the width and 10 is the height. Now the red square should be exactly the size of our sprite. Nice. That's looking right. Nice. That's looking better. Okay. I do think bat speed needs to slow down just a tad, but let's get rid of the red here. Okay. We're close. You know, the bat is now chasing us. Oh my god, that was way too fast. Wow. That was way too fast. We must be doing... We might have to plop these down. I don't know. What would make it so fast is that we're doing more than one of these things at once. Yeah. Let's shift this down to maybe 0.5 instead of 2. So we have to be within 0.5 pixels to move leftwards. That might make it better. Gosh, no, it still goes wild fast. So I think what's happening is we're doing 2 bat speed shifting here. So in the case that we're within, because this is like, if our x's are similar, let's do the y one. If our y's are similar, that means we're at the same height, therefore just move us left. So we're within 5 pixels of the same height, then maybe we set... no, I don't know. Yeah. Because we don't want to add this one too, and this one's doing a... If we're less than the x and... Oh god. Less than but not equal to is the thing. So I think if we set, if this is the case where if the difference is smaller than 5, then if we're to the left of us, I think if this difference is 5, then if we set our entity x or entity y to be equal to the player y, then on the next frame we will still have an absolute value smaller than 5, so we will still go to match our x position, but setting our y to be equal to the player y would then cease any of these diagonals to execute another bat speed on top of that, because this is looking for only if the player y is greater than, not equal to the self.entity y. So I think that would fix it. And then here we would say self dot entity x gets our player x. So we get just the correct value. It might look like it jumps when it gets close to an orthogonal position, but it shouldn't move fast. Nice. Oh, that looked fine. That looked great. Yeah, it's too fast. It's too fast still. Oh god. So let's chill out on our bat speed a bit. Especially because there's gonna be obstacles in the dungeons, so like we really don't want them to be that fast. Well, that's maybe too slow. But that's cool to see the logic of it, you know? Cool. I like that. Yeah. So the idea is like it is kind of dumb in the sense that it doesn't change its directory if it's a diagonal away from us. It just moves generally diagonally towards us, if that makes sense. Like it'll only move completely diagonal is what I'm saying. So whether or not we're super above it or super to the left of it, it'll only ever go directly diagonal until it's equal to our Y position or X position, and then it'll go directly towards us. So it isn't super smart, but it does eventually get to us. You know, because like this kind of highlights that behavior. It moves diagonal, diagonal, diagonal until it hits our Y, and then it moves directly towards us. So it doesn't always move directly towards us, but it does move generally to our direction at all times. It's ugly, but it's also kind of cute. Like it does, like the programmer art bat is growing on me. Okay, so I guess one thing I want to test is like maybe putting like a couple bats and just making sure multiple bat entities work. So let's try to do that. So we'll insert how do we do this loop? We say for an entity count. Where do we insert the geckos in a loop? Okay, all we do is a loop. Okay. It should be easy enough. We just need to give it... Oh, we need to give it... Okay. For right now, I'm just going to say we're going to do another table.insert of another bat. This one's at an X. Oh. Let's just see what happens if we try 2. We give it like a little bit random on the X and Y. Okay. See, I am worried that with multiple bats, they'll end up crossing each other eventually. See? And then they get morphed, which I don't like. But maybe we just give them slightly different bat speeds, and then they won't ever perfectly align. Because I don't like how they overlap like that. Because if we just stay still and then like match the other direction, they'll get closer and closer to being the same. Yeah. Yeah, and then now there's 2 like inside of 1. I don't like that. I think we just randomize the bat speed a bit, but we don't have a way to do that. Now we have a walk speed in here. We're not doing anything with that walk speed though. Let's say that our walk speed is our bat speed. Right now our bat speed's 0.2. So let's say one gets a 0.2, one gets a 0.3. And then in our bat walk state, we don't go by bat speed, but we go by self.entity.walk speed. So we're going to replace every bat speed with a self.entity walk speed. Oh, and all of these too. I don't know if this will work. Self.entity.walk speed. Because then we can give their own speeds, and then they shouldn't overlap. I mean, they'll still overlap and like collide, but they won't be exactly colliding because they have different speeds. You know? So like that does fix it. That does put them so that they can't exactly overlap. It does give them different speeds though, so I guess we could, yeah. I don't know, game dev is hard, man. Because like if we add collision detection between the bats, then we need to get a lot smarter with the AI. I don't know. I think we can make it slower. 0.15 and 0.2. Only a 0.05 difference. They just move too fast. Like, because they're going to stop right in the width of our fire spell. So I don't want them getting too... See, I think this is okay. Yeah, it can even afford to be closer than a 0.15, so maybe like 0.02 difference is still enough to just get them to not perfectly sync up, right? We just don't want them to overlap and just be the same bat entity. So as long as they're not yeah, 0.02 might be too close. Well, it's hard because the bats, this might be okay because in the level design, you know, we're going to have a lot of holes to fall into. Let's do 0.03 difference, but let's make the top speed one 15. And then we'll do 0.12. So 0.03 difference, but the max speed is a little slower. Because you know, we're going to have pits and stuff, and then they also are going to stop when they're like this close to you. So they shouldn't actually get to the point where they're overlapping each other too much, because you won't have the freedom to do that. I think that's a good. Yeah, because even there, yeah. I think that's okay, because you can tell there's two, and they're kind of going at you. I think that's okay. For right now, we'll call that okay. And we do it Y. I'm curious to add like one more. I feel like we can't add more than 3 because we have to get, you know, we have to have them all have different walk speeds. Otherwise, they can just overlap each other. This is cool though. See, they'll all move generally the same direction. This is okay though. The overlap would be fixed if we moved directly towards the player. I think we could do that. I don't know if we can do that with a tween or not. Because the first argument to a tween is like how much time does it do to tween it. Yeah, once they get bunched up, I don't like how they get all bunched up. But This will be different because they're only allowed to get bunched up when I like wait in one spot. But the truth is, they stop moving once they reach a certain distance from me. So if they can't get close enough to match our either X or Y position, then they won't get so close to butt like that. So I think we're good. You know, tomorrow I'll work on the spitting and the stopping once we're in range. And then yeah, and then we'll see if they get closed up, because I don't think that's I think that'll be okay. So let's look at our get diff. We added a new batless with the correct spacing. We loop through, we add a couple, we fix the width and height for our bats. We give it a different walk speed. We added 2 more bats. And then we're not using this bat speed constant anymore, so we'll take that out because we're doing it based on walk speed. And then we do our process AI for our bat walk state. That's basically all we do. So let's take out from our constants the bat speed because we're not using it. And then we'll commit with a message saying we added initial AI for bats. Cool. And then tomorrow we will try to get the bats to stop when they're just in our range of spellcasting. So like in a circle radius around us, they'll stop, and then they'll trigger an attack mode which spits like acid at us or something, and then damages us. So the goal is have it not be like the geckos where they just walk directly into you, but they have different attack. So the attack will be, once they're in range, they're just going to spit at you every 2 seconds and do half heart damage. Half heart damage. Maybe every 3 seconds they spit at you. So if you don't kill them within 3 seconds or knock them out of your spellcast range in 3 seconds, then they'll spit at you and damage you. This is cool. I mean, this is coming together. This is faster than I thought it would be for this. I thought this was going to be the hardest part, but maybe the level design with dungeons, once we add the spitting and stuff. I think spitting will be fun because we can maybe add a little animation, a little splash animation or something for it. That should be fun. And then we have to come up with like a new edge pit for the dungeon so that you can be knocked into the pits of the dungeon instead of just the square pit that we have in the overworld right now. Because the whole thing is, in the dungeon, you have to kind of push boulders and maneuver around them while defending yourself from the bats. And if they get close to you and spit, the spit will hit you and knock you back into the pit. So yeah, I think that's a good idea for this first dungeon here. And then I mean, I guess we're good to go. Yeah. Thanks for watching. We'll run credits here for our supporters, and we'll look for someone to raid. You know what? I always like raiding Brightside because he's super friendly. And then we'll call it a night. I'll be back tomorrow for more Bat AI stuff. Thanks for hanging, Loki. Hope you have a good night. Take care.